I'm Carrie. I'm going to do all the presenting today. Darren will be behind the scenes answering all the questions in Discord because I can't read, type, and speak at the same time. So he'll probably switch off his camera and say goodbye here in a little bit, but he'll be there answering your questions when I can't. There is a link to the slides here, a shortened link, rb.gy.mkl158 if you want to use that, but also in the slides channel on Discord, you'll find the link. And Darren, can you post that in the chat for GoToWebinar as well? So you'll have a link to that. My name's Carrie Roberts. I have a background in PC and mobile application and web app development. I was a web app developer back in 2010, about to release a new web application that I was the primary developer on when my application failed the penetration test miserably, or security audit of my application that said my application was completely hackable for things like SQL injection, cross-site scripting. And at that time, 2010, I knew nothing about either of those. I had never even heard those terms before. So that was a depressing day for me at work to find out that my application was completely hackable for things I knew nothing about. And for a bit, I just wanted to quit. But then Darren talked some sense into me, encouraged me to go learn about security. And that's what launched me on this path of seeking training through the SANS Institute, where I got excellent training. And as I sought to become a security expert, I ended up being able to be a pen tester for Black Hills for 3 years. And then I moved on to the red team at Walmart for a couple of years, and the last couple of years on the blue team, so I could round out my skill set. I am one of the Atomic Red Team maintainers and developers. So if you've looked over there or participated over there, you probably see some interactions with me there. Atomic Red Team itself is a library of scripted attacks. So you've got hundreds of attacks that say where you can go in and say, if I wanted to do this type of attack, what would I do? And it will tell you the exact commands to run from which, executor like PowerShell or command prompt, whether you have to be an admin, gives you all the information. Kind of that missing piece. If you're familiar with MITRE ATT&CK, it tells you all about attacks and kind of describes them. But if it came right down to it and said, okay, can I see this attack happening in my environment? Or if I'm an offensive security professional, can I do this attack? There's a little piece missing, which is, what do I actually type in to make this happen? Or what tool do I use? And that's where Atomic Red Team fills in. It was started by the good folks over at Red Canary, and it's free and open source and community developed. They're actually, right, last I looked, 170 contributors to Atomic Red Team. So we've got a whole community submitting tests to this library of scripted attacks, and that's what we're going to be looking at today. This webcast is really a small subsection of a larger class we teach that is not free through Wild West Hacking Fest. It's a 4-day, 4 hours a day class where we cover what you see there, all things attack emulation that are free and open source. Today, the webcast, we cover essentially part 1 of Atomic Red Team. And so in the class, we'll go into more detail about Atomic Red Team. We cover more on MITRE ATT&CK and the Attack Navigator. And we go into other attack emulation tools like Prelude Operator, MITRE Caldera, Purple Sharp, Mortar, and the Splunk Attack Data Repository. And we also go over the Vector Purple Team Reporting tool, which is excellent and useful. Today is 1 hour of lecture followed by 2 hours of lab time. You can use your 2 hours of lab time anytime within the 5 hours after class or until midnight Eastern. So hopefully that's flexible enough for everyone. We'll be providing support during that time, or via Discord. And the slides are there, so you should have everything you need. And the slides are also in the slides channel on Discord. Some people might be asking, how do I get access to the labs? We haven't posted those details yet. But there is information at the end of the slides, and we'll be posting that information in the slides channel near the end. So real quick, to get everyone on the same page, let's talk about the MITRE ATT&CK matrix, which is what we're looking at here. The matrix is a nice table that lists across the top tactics or general categories of things that attackers are seen doing today to attack people and networks and companies. And so they're broader categories. So we see things like defense evasion. So there's certain techniques that attackers use in order to evade defenses. And there's also other tactics for gaining access to credentials or discovering information about the network. And so we see those tactics across the top circled in red. And then going down under each tactic, we have techniques. So we have our tactics and techniques. So under credential access, we see that attackers tend to gain access to credentials through brute forcing or finding password and password stores like your Chrome browsers or KeePass, or they might do input capture, so key logging on a system. So that's an example of techniques. So the important thing to take away from this excellent resource for today's discussion is the fact that each of these techniques, so we have tactics across the top, techniques going down, each of those techniques have a specific number assigned. So in this case, the one I've circled, T1003, is the technique number, and then you might optionally see a decimal point and then a sub-technique number. So this would be technique T1003 with a sub-technique or more specific part of that technique, that's 003. So that's important to point out because everything in the Atomic Red Team library of scripted attacks ties back to the MITRE ATT&CK Framework through this technique number. Okay, so let's take a look at some what we find in the Atomic Red Team library of scripted attacks. This is an example of an atomic test, and sometimes I call this an atomic for short. So when I say atomic, I mean a single atomic test. So this is one atomic test in the library called disable user account control using reg.exe. So it literally just says run this command, which changes a registry key that will disable user account control. And so that's something an attacker might do on a system to allow their things to run without prompting the user and highlighting the fact that they may have been compromised. It tells us, it has a nice description here. It tells us to run it on a command prompt from an elevated context. And then it even gives us a cleanup command, like after you get done, doing this, if you want to set the system back, you can run the cleanup command. So that's an example, and we see this is a link too if you want to click on it in your slides. This is technique 1548 in MITRE, sub-technique number 2. Another example from a different technique, T1003, sub-technique number 2, is registry dumping some registry hives, the SAM system and security. So these hives contain credential information, and attackers like to make a copy of those, exfiltrate them, and use them offline to extract credentials from them. So if we see in our environment somebody extracting these 3 registry hives, that should highlight a potential problem for us that we want to investigate. Another example is enabling the guest account. So here we have another atomic test under technique 1078 that just enables the guest account to allow an attacker to maintain access without adding a new user by just using the built-in guest account. And in this case, it adds the user to the RDP group so they can RDP to the box and gives them administrative privileges. So these 3 examples I give you aren't something that your AV or EDR is likely to block because they're kind of features of Windows and not necessarily bad, but they're also uncommon. So if you see the guest account being enabled in your environment and you know that that is not a typical business process for you, then you're going to want to know if something like this happens. So this is an easy thing for you to keep an eye on in your environment, writing a custom detection to watch for this done. On the other hand, if you're an offensive cybersecurity professional, you can use these techniques to maintain persistence. Okay, so here's another example using the bits admin tool. I'm not showing the whole atomic test from the Atomic Red Team library, but these are the commands from the atomic test, and it's just creating a bits admin's job. Bits admin is a background downloader built into Windows, Microsoft Sign executable, and you can use that to create jobs to download things in the background. So here we're downloading bits.bat, and then we're using this special set notify command line option that says when you get done downloading this, do this thing, which in this case is just B9 running notepad.exe. But you can imagine that an attacker would use this to launch their own malware. And the interesting thing about that, and why an attacker might want to do that, is because the parent process for the malware in this case that we're simulating is going to be SVC host, because that's what happens when bits admin starts up a process. So it may go unnoticed because it's being launched, parented by a trusted process. So you might want to ask yourself, oh wow, well, of these 4 examples that Gary just showed, which of how confident am I that these would be noticed in my environment, blocked in my environment? There's really only one way to know, and that's to try it. Your vendors will tell you, try to tell you what level of coverage, but until you try these things, you can't be so sure or so confident. So this brings us to talking a little bit about why is it important to emulate attacks. So for one thing, there's a lot of things that have to be in place in order for a defender to defend a network against attacks. So imagine you have employees working on the endpoints. That endpoint has to be configured to pay attention to certain events and ignore others. We don't have the resources to log everything that happens on every computer everywhere and then search through all that information. So we want to only be capturing important events, and then we want to send those important events to some central collection spot where we can search through it, and then we want to apply some logic to search through it. And if something comes up that's suspicious, we want to have maybe an analyst review that, and if that is confirmed to be bad, we want to raise an incident to our incident response team where they can contain and eradicate that. So there's a lot of things in there that could go wrong. So maybe we have great alerting logic that can search through data and find bad, and it does a really good job. But if we're not capturing the right events and our pipeline to get those events to our central collection agency isn't working, then we aren't going to be able to protect our environment. So that's why Atomic Red Team is valuable, because now we can take these simulated malicious cyber attacks and we can run them and we can validate, yes, we're capturing the right events, yes, they're going where they need to go, yes, our alert logic is working to find that, and it's really getting seen by analysts and ultimately raised as an incident like it should be. Okay, so as we get in, we're going to switch over and do some demos here. So as we get into the nitty-gritty of Atomic Red Team, I want you to keep separate in your mind that there are 2 different things we're talking about here. So everything I've talked about to date, or to this time, is the Atomic Red Team library of scripted attacks. It really just is that library, like that web page you saw that said, here's the name of the test, here's the description, here's the commands you run, here's the cleanup commands. So that's the library of scripted attacks. Now you can do what you want with that library. You can learn from it. You can think of things you want to try on your next pen test or red team. You could, as a defender, you could copy and paste those commands out into command prompt, PowerShell, or whatever. I'm talking Windows centric here, but there are atomic tests for Linux and Mac OS as well. But when you're doing something like continuously validating that your detections are working, like maybe you wrote a detection 6 months ago and you want to make sure constantly that it's still working. So maybe every month or every week you want to rerun the atomic test and say, okay, I did the bad thing. Do I still see that the bad thing happened? In that case, we want to automate the running of this library. And to do that, we use something called an execution framework, or that I call it execution framework. It's a tool that reads that library and follows the instructions. So instead of you having to copy and paste commands out, put them on the right executor, PowerShell, or command prompt, be admin or not admin, etc. You can just have the execution framework follow the instruction. You say execution framework, run these 100 tests, and you can script that to happen every week, say, and then you're validating your detections week to week, month to month. and having confidence that everything in your pipeline is still working. Okay, so this is where we jump out, and I will show you that what I am presenting from here is the lab VM that you have access to for this class, that you'll get the information about at the end of class. And so it's just a Windows VM, nothing special about it other than I installed Notepad and Chrome and put some shortcuts on the desktop. But other than that, nothing else is special about this VM. So you can definitely do these labs on your own VM. So what you're gonna wanna do is start up Chrome, and in Chrome, you have links across the top. So that's shortcuts to a lot of the MITRE ATT&CK, Atomic Red Team stuff, and additional things that we cover in our paid class. But you're gonna wanna click on the labs, which I have open here. So in the labs, you have a link to the slides, and these are the 7 labs that you can complete. You can also download these labs to maintain access after you lose access to the lab environment. So these are the 7 labs. They're very detailed. If you aren't able to stay today and complete them, you can do that on your own time. And you can also find us at other times on Discord and Slack to ask questions if you get stuck. Okay, and so I'm gonna go over to this new tab, and I'm gonna go over under Art Atomic Red Team, and I'm gonna open the Atomic Red Team GitHub. So you have the same shortcut on your lab VM. And I'll open this up. Okay, so Atomic Red Team, the library, is found in GitHub, and GitHub is a great place where you can put code-like things and allow a lot of people to contribute without everybody overwriting everybody's changes. So that's why it's in GitHub. And you see here that the project has a lot of files, and when you first come here, it can be a little overwhelming, but there's really only, a lot of these files are just supporting files. There's really one main folder that you will be concerned with, and that's this atomics folder. That's where the library resides. But before I click there, even more important than that is this wiki. Sorry. Okay, so over on the wiki, it has some introductory information, but if we go over to the sidebar to some additional links, we have about Atomic Red Team. And so this goes through everything that I'm going to go through with you today, and probably even more detail. So you can review that, and then it talks about how to execute the atomic test. You can do it manually by copy and paste, but you can also do it with an execution framework, which we'll be covering in the rest of this class too. And there's a section on contributing. If you want to contribute back to Atomic Red Team by submitting a test or writing an issue, you can read all about how to do that there. And there's also frequently asked questions. Okay, so don't forget about the wiki link here on Atomic Red Team. It has all the information that we're going to talk about today. So we go back to Atomic Red Team, and we go into the atomics folder, and we see, with the exception of this first folder, a bunch of folders that are named by their MITRE technique number. So I mean, it's very clear that everything in here is tied to Atomic Red Team, so or to MITRE ATT&CK. So if there's a technique number here, a technique folder, then we have at least one atomic test for that technique number. If I go over here to the MITRE ATT&CK, there's also a shortcut here, Attack Navigator, Atomic Red Team coverage. So Attack Navigator is an interactive MITRE ATT&CK matrix that you can click on things. But here we load up every one of these techniques on MITRE ATT&CK that are colored red have at least one atomic test written for them. So you can see that the coverage is pretty good, but it's very missing on the reconnaissance and resource development side, and even on initial access, but it's pretty good in here. We have nothing for some of these areas here, but that's being developed now. So this gives you a quick idea of how well does Atomic Red Team cover the MITRE ATT&CK space. Okay, back to here. So let's take a look inside of one of these folders. Let's go with T1016. So inside one of these folders, you'll find at a minimum a YAML file with the same technique number and a markdown file. These files contain essentially the same information, but but the markdown file is a lot easier to read. So when you're contributing to Atomic Red Team, you do that by adding a test to the YAML file, and you can kind of read this. It's more machine readable than human readable, but it has all the information about the description and the attack commands and the cleanup commands, but it's not very fun for humans to read. So this repository in GitHub Atomic Red Team automatically generates these markdown files from the YAML files, and it's a lot better to read. So let's look at the markdown file. So the markdown file describes the name from MITRE ATT&CK of the T1016 technique. And it also copies in right from MITRE ATT&CK's website the description of this technique. And then it lists out all the tests. So here we have 8 tests. We have some tests for Linux and Mac OS and Windows. Here's the first test. Attackers who gain access to a network are likely to run commands like these to gain information to fuel their next moves. And so they might run these. So we see this is supposed to be run in the command prompt. So if we wanted to emulate an attacker who just gained code execution within our environment, we might copy these out and paste them into the command prompt, and we could run those manually. So we can see that we can learn from that and do that. I won't do that right now, but I'll show you another test. Let's go down to this test. So this test says it's an egress port checker. So it's checking what ports can the attacker use to reach outside of the network. So they need to know what's open outbound so that they can exfiltrate stuff through that or set up command and control channels. So they might try to scan those ports to find out which are open. And for this one, you can see we're supposed to run this atomic test in PowerShell, and it's a little bit longer. It's maybe 20 lines, but there's some special syntax in here. There's this hashtag squiggly with the name of a variable, and we see that that variable lines up with the name of this variable. So now we've got some configurable input arguments that as we execute these tests, we can customize. So here it's saying what ports do you want to scan. It's by default, it's going to use this top128.txt file that comes with Atomic Red Team. But you can use this same test and say, no, when I run this atomic test, I don't want to scan the top 128. I want to scan these other 10 ports instead. So at execution time, you could swap out that port file with your own port files. So these input arguments make the test configurable for your environment without having to write a new test. But as you can imagine, that starts to make it harder for us to we can't just copy and paste this out now and execute. In PowerShell, we'd have to paste it in Notepad. We'd have to replace these variables with their default values here, and then we could execute. So that's what brings us to the desire to have an execution framework that will do that for us. It'll swap in the input arguments. It'll let us set non-default values for the input arguments. It'll log what ran and what didn't. And so let's go over and take a look at that. So right now we're in the Red Canary organization, Atomic Red Team, but if we back up one level, instead of Atomic Red Team, we go over to Invoke Atomic Red Team. So this is the execution framework. We also have a wiki here. So let's jump over the wiki. And over in this sidebar, we see all the sections of the wiki. We've got installation, importing the module, or installing the execution framework, importing it for use, how to use it to list the atomic tests available to run, how to get or check our prerequisites. So some tests have prerequisites to say, in order to run this test, you first have to have ps-exec from sysinternals downloaded. So some tests will look at that, have prerequisites. And how to execute atomic tests locally, meaning on the machine where we installed Atomic Red Team, but we can also execute tests against a remote machine through PowerShell remoting in the case of this execution framework. This is just the execution framework that comes from Red Canary. It's a PowerShell execution framework. It's cross-platform if you install PowerShell Core on Mac OS and Linux. But there's other execution frameworks too that don't require PowerShell remoting to be enabled to execute against a remote system, and those examples of those are Prelude, Operator, and Caldera. So keep that in mind. We're not going to talk about remote today, but this wiki talks a lot about it and explains how to do that. You'll notice that these sections line up really close to the 7 labs you'll be doing in class today, or in the 2 hours of lab after class. So you have another version of the same information here on the wiki. So that's the wiki. Don't forget about the wiki. It's a very valuable, answers a lot of your questions and has a lot of detail. So back in Atomic, or actually over here in the wiki, it tells us how to install Atomic Red Team. And it's just copy and paste a simple command. And you'll be doing that in your first lab. I've already done it for the demo today because it takes a little while to download, but I walk you through that in the first lab. Okay, so let's take a look. Once you install and import Atomic Red Team, you'll have this function called Invoke Atomic Test. And once you have that set, you can give it a technique number to say which test you want to run. But before we do that, I just want to show you there's a special option. Instead of giving a technique number, you can say all. And you want to, it's not a great idea to run all the tests at once, but if we tack on this extra option to show the brief details, which just lists the name of the tests that are applicable to the current operating system, so Windows. So it's going to list the name of all tests that are an option for me to run on Windows right now. And here we go. So we see all these technique numbers, sub-technique numbers, test numbers. Looks like there's a little error there we need to fix. And so there's quite a few options. I'm going to cancel out of this, but it gives you a little idea about how many tests are in this library. Okay, so barring that, let's go look at T1016. And again, I'll do the show details brief, which just lists the names of the tests under technique T1016. This is the one that we were looking at for a minute, system network configuration discovery on Windows. And test number 1 we looked at. Let's take a closer look at test number 1. So we can specify a specific test number here, or numbers. You could do comma separated list, but we'll just look at test number 1. And instead of show details brief, we'll just do show details. And that gives the full details for that specific test or test that you specify. So here we see this similar stuff to what we saw in the markdown file. And we see this is the one where we were running ipconfig and various things where we said we could copy and paste that out into command prompt and run it. But with the execution framework, we can just say, can you please run this test? So if we remove the show details, it will follow the instructions. It will start up behind the scenes so that you can't see a command prompt, and it will execute these commands and then return the results to the screen. So here we run test number 1, and then it spews all the information from running those commands to the screen. And now we've just emulated an attacker doing reconnaissance on our network, and we could go into our telemetry, our defenses, and see if we noticed that happened and validate that our detections would work. And let's see, let's look at another test. Okay. A great way to look through the library, the Atomic Red Team library, is using the search menu on GitHub. So I'm looking for a test called disable UAC, because I can't remember what technique number it is. And okay, it's T1015, or sorry, I can't even talk, 1548002. So let's look at that test. That's the example I gave on one of the slides. So it's just going to, it says elevation is required, and then it's gonna set this registry key to disable user account control. So this is something you likely want to keep track of in your environment if that's not standard. So we could say T1548 test number 1, and We could show details to make sure we're on the right test. Yep. Before we do that, we could use this option that says check prerequisites. And so sometimes tests have prerequisites. This one doesn't list anything, but it does say we have to be elevated, and we're not. So if we were to run, check prerequisites right now, it's not test number 1, it's test number 8. Okay, prerequisite not met. You need to be elevated to run this. So let's jump over here. Run as administrator. There's our UAC prompt. Haven't disabled it yet. Let's try to run the same thing. If copy and paste will work. Okay, now it's happy. It says, yeah, you have everything you need to run this test, so we can remove check prereqs, and when we run this, it's going to set that registry key. Oh, wow. Defender knows about that. Maybe it doesn't like that test. Now it's probably hanging us up too. This is a new demo, of course, that I made up right before class, so.
Dun, dun, dun.
Dun, dun, dun. Let's see if we can cancel out of that. Okay, let's just do this. And we're going to turn off Defender for a second to do this demo.
Also, good job, Defender.
Yeah. And then my copy and paste isn't working. I usually like to pick examples where you don't have to turn Defender off, because then people think that the tests aren't valid. But there's a lot of things in Atomic Red Team that aren't bad in on themselves, like the use of bits admin. And so okay, that's just a bad example. We'll wait, we'll let this thing go, because there is a timeout of 2 minutes on that, and we'll see what happens when it times out as an example, and we'll come back to that. In the meantime, there's another test that's a good example, and it's called deleting a file with secure delete tool, sdelete from sysinternals, because then it makes it hard for defenders to figure out what the attacker's been up to. So let's find that, and we find that over in 1485. So let's do invoke atomic test, and we'll show the brief details so we can see. Oh, there's only one test. So we could, if you want to run all the tests for a given technique number, then you just don't specify any of the test numbers, and it'll do them all. In this case, there's only one, so we can run that. So let's go ahead and try and run this and see what it does. It gives us an error that says sdelete, the term sdelete is not recognized as the name of the commandlet. So if we take a closer look at this test by showing the details, we see that there's a dependency that the secure delete tool must exist at the location, at this location by default. You can change it. And we see a nice example of input arguments being shown in red. So these are the special variables that say replace this with the input argument here. So you can, when you run this, you can optionally use non-default values for what file to delete and where the sdelete executable is on disk and what it's called. So you can customize it for your environment, but it uses defaults, which we see the defaults filled in here. So we see file to delete, and the default for that is 1485.txt. And the default location for sdelete is here. So if we actually would have ran the check prerequisites command, we would have seen that we don't have what we need to run this test. So let's run that. It says prerequisite not met. The secure delete tool must be at the specified location, and it's not. And it says try installing with get prerequisites. So this is where the execution framework is helping us out. So now we don't have to go out to the web and find this tool and download it. We can just have the execution framework do it for us. And we could say get prerequisites. And here it is downloading from Microsoft, extracting the zip file and putting sdelete.exe where it's supposed to be. So now if we say check prerequisites, it says, yeah, you're good to go. You can run this test and it should work. So now we can get rid of that and try this again. And it said sdelete deleted t1485.txt. And so at this point, you could look in your environment to see if you can detect that that happened or that somebody is using the sdelete tool. Okay, cool. Another thing to talk about is that these input arguments are configurable. So we'll talk about how to do that. So maybe the file we want to delete is not 1485. Maybe it's some sensitive file that we know about. So we could say, we could make a file called delete me.txt and put something in it. Okay, we got delme.txt. Now we're gonna configure this atomic test to use that as the file to delete instead of what we were before, just to show how we can use the execution framework to change input arguments. So there's a couple ways to do this. One is we could ask it to prompt for input args. So it's going to ask us for each of those input arguments what we want to use. And it says enter value for sdelete.exe. So if our sdelete tool is somewhere other than the temp directory sdelete, we could specify that here, but we're not changing that, so we'll just press enter. And then it says enter a value for a file to delete. So here we're going to do C users art delme.txt. There, and then it says, okay, we used sdelete to delete this file, and that file's gone. So, I mean, very simple example, but you can see that these tests are configurable, which helps us do things like match our environment, but also evade weak AV and EDR controls. For example, if we try to run the Invoke Mimikatz PowerShell script and we're downloading that from the author's repository, that could be getting blocked just because AV has decided to block everything from the author's repository. So in that case, we could modify the default URL to download Invoke Mimikatz from, and we could host it somewhere else, like on an unpublished, unknown URL that wouldn't be blocked by default by AVs, for example. So that's something that you'll want to do. There's also another way to specify input arguments. I won't demo it, but I'll show you how to get to the information. If we go back to the Atomic Red Team GitHub, actually the Invoke Atomic Red Team, the execution framework, we go to the wiki here, specify custom input arguments. And the way we did it was interactive. We said prompt for input arguments, and we had to type those in. But you can imagine if you want to use custom input args from an unattended script, so something that runs atomics again and again, week after week, you don't want to have somebody there having to type in these input arguments. You can specify it also using a dictionary or hash table, I forget what you call it, and you can pass that in. And so you can have a PowerShell script that sets your custom input args and passes those to the execution framework. And so it can be done unattended. There's also cleanup commands. So let's go see what happened to that example that bombed here. It says the operation, oh, it timed out, but it says it completed successfully. Okay. Wow. For some reason that just takes forever to run and I don't actually know if it did. Okay, I'm giving up on that. I'll figure that out for the next demonstration. I did just use this interactive flag. Most of what this execution framework does, it does stuff in the background. It writes everything to a file in the temp directory, and then it reads that back out and spews it to the screen at the end. And that's really handy so that you can redirect all of this output to a file to later review and decide, did this test work and do what it was supposed to do? For example, did I get credentials listed to the screen from memory, or didn't I when I ran Mimikatz? You can do that because the execution framework does not tell you whether the atomic test worked. And I do worked in quotes because worked is kind of subjective. And it's also very difficult to automate the decision about whether something worked. So whether or not credentials came to screen, I mean, some things are easier to check. Did this file get created? Did this registry key get set? But other things are harder. Did a process spawn another process within a certain amount of time? So the execution framework doesn't provide an indicator of success, but it does show you, it does record what it attempted to run and when. So if we look, there's an execution log over in the temp directory, which we can look at. We don't have Excel installed, so we'll use import CSV and look at that log. Invoke atomic test execution log, and we'll put it in a grid view. Okay, so we see that we ran system network configuration and discovery. It was test number 1 under T1016, and then we ran the sdelete tool 3 times. You also might have noticed this GUID. So the GUID is a unique identifier for the test. And if we do the show details on a test, you also see it there. So you see this GUID, and you can specify to run a test by GUID. So you could say, instead of test number, you could say test GUID. And then you could copy this in and execute it that way. And you might be wondering, why in the world would I want to do that? Well, the test numbers are not that reliable in terms of if you're running this from an unintended script. So the test number is really only indicating where in that YAML file that we talked about, where all the tests are listed, where this test shows up. So if somebody adds a test before our test that we're running, test 5, say, they add anything above that, this suddenly our test 5 is really now test 6. And if we have a script that runs every week running test 5, we update our repository to pull in the latest test, and suddenly we think we're running the old test 5, but really we're running the new test 5, which could be doing something completely different. So in order to make that reliable, we have this option to execute by GUID, because then it doesn't matter what order the test shows up in the file, what different contributors might do to change that order, and it doesn't rely on the test name. So sometimes the test name changes slightly. So maybe instead of, what's the name of this test? Instead of Windows overwrite file with sysinternals, maybe somebody decides we don't need Windows in the name. So suddenly the name changes too, so you can't rely on that. So that's why the GUIDs are here, is really for being consistent in what we're automating in an unattended way. So you may have questions about that. Darren, are there any urgent questions we should address before I go over the remaining slides?
I don't think so. I've been answering quite a few, but I haven't seen anything that you need to talk about.
I have one in good webinar. Is there a way to bundle specific atomic tests to simulate a certain APT?
Yeah. So the Prelude operator and MITRE Caldera tools are built specifically with this in mind, where you can kind of drag and drop and say, okay, run this and then run this and run this to follow a multitude of steps that APTs use. In the case of the simplified execution framework, the PowerShell Invoke Atomic Red Team execution framework, to do that, there's no like invoke APT 38, if that's even a thing, I can't remember. But you can simulate it pretty easily. You could have just a PowerShell script that was as easy as invoke this test, which would be invoke atomic test T whatever, and then invoke this test or that test. And so it's basically a PowerShell script that all it is invoke test 5 with these arguments, invoke test 6 with these arguments. So in that way, yeah, but not really built in to where you could just say invoke this group. But you might be interested to look in the capabilities of those other free tools that are more built with that in mind. Okay, back to the slides. We're getting near the end here. So we're going to jump ahead because I demoed all that. Okay, so yeah, that's the execution log. I showed the execution log, which looks like this. So for getting started, I provide a link here to a spreadsheet that just has a smaller subset of the whole Atomic Red Team library, and this is Windows specific, but it's just some of the kind of my favorite tests because maybe they're less likely to be blocked by default because they have valid uses to an environment, and or they're more straightforward or easier to set up or understand. And so I've listed those as, I think maybe about 30 of them. That's like, well, if you're kind of overwhelmed by the giant library, here's a place you might be able to start looking at a few tests. And so we talk about how should we set this up in our environment, or could we set this up? So there's a variety of ways. So I've got here this computer shown in the middle, and it's got this G, which means golden image. So we could take something that represents the same sort of system that we would give to new employees when they're hired, and then we could install Atomic Red Team. So that's what that symbol represents. And then this arrow says we're executing the atomic test against ourselves. So we install Atomic Red Team on this machine, and we also invoke the test against the same machine. So we're doing local execution instead of executing against a remote machine. And then we got our little symbol for AV here. So I would suggest running the atomic test both with AV blocking controls turned on and with the blocking controls turned off, because prevention is ideal, but detection is must. So that there are a lot of like AMZ bypasses and variations that can be made that allow these tools to run. So in the event that there is a workaround that allows these techniques to run, will I be able to still tell that it happened? So will I be able to detect? So in any event, you install Atomic Red Team, you run the test kind of like we do in the lab, doing from a representative image, and then you ship those logs off to your production collection, central collection agency, where you collect all the telemetry from endpoints. And that's where you can run your alert logic against that production instance of telemetry and decide, do my detections work, or to develop those detections. So one of the drawbacks to this is actually installing Atomic Red Team by itself is fairly intrusive, because the execution framework has to install like a YAML module, because PowerShell can't read YAML by default. So it's installing a YAML module, it's making configuration changes, it's downloading that whole library of scripted attacks, which looks a lot like malware. And so just by virtue of downloading that folder of atomic tests, the library, and the supporting files, I forgot to talk about it, but there's also optionally a source and a bin directory in each one of those technique folders, which contain the payloads to run some supporting executables or PowerShell scripts. So by just installing this, if you were to install this at work, a bunch of hopefully a bunch, and likely a bunch of alerts will go off and bells and whistles will be like, I don't like this and I don't like this and I'm blocking this, because all that stuff looks bad. And so if you're gonna play with Atomic Red Team, be sure you do it in a test environment to start with. I wouldn't just go to work and install this on your work machine. You want to play with this and get comfortable with this in a disposable environment, and then only take those tests that you fully understand and trust, because you understand what they're doing and how they're doing it, and potentially run those in a production environment depending on your risk aversion level. Another option is to execute tests remotely. So this is kind of nice, because now we install Atomic Red Team on whatever system, our own system, non-corporate system, and then we can execute against a remote machine. So an actual person, so Bob's actual machine, who's an employee, we can connect through it through PowerShell remoting and say, do this one thing. So set this registry key, for example. So it's very light touch. It really only does the attack technique and doesn't create all this extra noise from installing Atomic Red Team. So that's nice. And Prelude Operator and Caldera work over a C2 channel, so it's not PowerShell remoting, but it has the same idea where it's light touch on the remote system that you're actually testing on. So I think this is showing the same thing, where you install Atomic Red Team here, and then you execute on a remote golden image with AV on or off or both, to see what your coverage is, and then sending that telemetry to your production system where you can test detections. As I mentioned, the lab that we provide you after class is just a standard Windows installation. So if you want to run these labs, you can download them and take them off on your own and run them from your own VM, and play with it. And I mentioned you don't want to run all the tests at once. You can in this lab environment that we give you. You can with your own VM if it's disposable and you don't care. But it's just that there's so many tests and so many interactions that happen that you end up basically somewhat disabling the machine, if not fully disabling it. And so much has went on at once, you can't even really make sense of the telemetry. So it isn't really valuable to just basically blow it up. So you want to do things in a controlled manner. But to set up those VMs, you could download a free virtual machine from Microsoft and just run it from there. Or you could set up some labs in the cloud, which you can do with tools like Detection Lab and the Splunk Attack Range, which will spin up a whole domain joined environment. So you 3, 4 or more VMs, including a Splunk forwarder and a Splunk system if you like to work with Splunk, and a domain controller, a Windows machine, and the Splunk Attack Range comes with a Linux VM with Atomic Red Team and Caldera already installed, Atomic Red Team already installed. So it makes it easy to try some things and to be able to look at telemetry at the same time. There's a link to more information about those 3 things there. Remember on the wiki that there's a whole page on contributing, and it answers a lot of the questions that we get from folks, that the maintainers get from people who want to contribute new tests, and we encourage you all to contribute. I'm on the Atomic Red Team Slack workspace regularly, so if you are nervous to get started and you want to reach out to me and say, hey, I have a test idea I want to do, but I'm new to GitHub, new to pull requests, you can reach out and I'll mentor you through that, because we'd like to see you contributing more in the future. Here's the Atomic Red Team Slack workspace. You can join here. I'm OR1=1 over there. Darren's Mr. OR1=1. So we're available there for questions. I monitor this better than Discord, especially for Atomic Red Team stuff. So you can reach out to me there if you want help contributing, but also read that wiki. Also a reminder that this webcast is a short introduction to what we cover in more detail with Attack Emulation at our 16-hour class through Wild West Hacking Fest. There's a link to that there. So now the moment you've all been waiting for access to the lab environment. So you have allotted 2 hours of lab time. You can use a VM that gets assigned to you up through midnight tonight. So if you're not ready to start it right now, you want to start it in a couple hours, don't start up your VM yet because your 2 hours will start ticking. So you want to wait till you're ready to do the labs to start up your VM. So you're going to go to the control panel and enter the email you registered with, and it will show you what IP to make a connection to through remote desktop and what the password is and username. And then it'll have a button there that allows you to start your VM, and that will start your time and it will start your VM. It takes up, it usually only takes a few minutes to start the VM, but if it happens to do updates, it can be 10 or 15 minutes if you're unlucky enough to have your VM updating. But give it some time to start up and then connect remote desktop. DM Darren or I if you're having trouble connecting. I uploaded the registered email addresses 2 hours ago, or 2.5 about. So if you signed up in the last 2.5 hours, I haven't had a chance to input your email address that gives you access to the labs. So give me a little time here right after the end of the class to get those added. If you still haven't been listed, if it's still not giving you an IP address and you're not a late register and it's been 20 minutes, you can DM me and I can get you added. Once you're connected, you'll be connected to the same looking VM that I am, and you're going to start a Chrome browser where we have the bookmarks to the labs and Atomic Red Team. You've got these 7 labs to do, which tell you how to install Atomic Red Team and import the module, which I didn't show you for interest of time, but it walks you through that. Don't be nervous when you run into errors when you install, because we do that on purpose so you can see what kind of hassles you're going to run into when you install this and how to work around them. So keep reading down in the instructions if you get errors to learn how to work past those. And then we talk about listing what tests, with show details, how to check and get your prerequisites, how to execute tests locally, and specify custom input arguments, and then clean up after yourself. And there's also some optional stuff down below, like joining the Atomic Red Team Slack workspace and setting up your own lab. Thank you for joining. I'll stay on here and watch for a little longer for questions. Darren, if there are questions I should answer, let me know. But that's it. Post your questions there and try out that lab access.